Part B of this problem. Now we have two workers attempt to move the sun rock by applying a vertical force at A and another at D. Determine these two forces if they are to be equivalent to the single force at part A. That means now we want to create exactly the same effect of the moment that we got in here in part A, but now with two forces. One force applied at A, vertical, like this, and the other one applied at D, like that. We can choose a variety of combination of forces. However, if we want to make it more simpler, we go and say that the forces are going to be equal. That way we will have couple. A couple that we know its moment is going to be the perpendicular distance times the force. Now, we got to match what's going to be the value of the force, and for that we will use the value of this moment. This moment is going to be the one that we use to calculate the forces. Hmm. So we will have to work now with a different rectangle triangle to obtain the perpendicular distance between this force or between this action line and this action line. That perpendicular distance is going to be given from here to here. So we can replace everything and we can work with a rectangle triangle that goes from A to D, like that. That rectangle triangle will have a 30-degree inclination. Now we're going from A to D. We know there's going to be one force going down in here and another force going up in here. Or that will depend. That will depend on the sign of the moment. However, we know we got two forces in here. So the perpendicular distance between these two forces is gonna be dx. So we go and calculate dx. Dx is going to be equal to the hypotenusa times cosine of 30 degrees. What's going to be the hypotenusa? For this situation, the hypotenusa is going to be the addition of 0.4 plus 0.35 plus 0.3. That means 1.05 meters. So replacing in here, we'll get 1.05 meters cosine of 30 degrees. That will deliver 0.909 meters of separation between these two action lines. If that's the case, we know that the moment of this couple is going to be equal to the perpendicular distance, in this case dx, times the forces. Since we know what's going to be the moment and we know the perpendicular distance, we solve for the force. Force is going to be equal to the moment over distance. That means 230.34 newtons meters over 0.909 meters. Once again, meters go away and we only left the newtons. The magnitude of that force that we require to create exactly the same effect and get an equivalent system is gotta be 253.45 newtons. That's the magnitude of these forces. That's my equivalent system. However, I need it to be negative, oh, positive, as it states from the result of A. To obtain a positive moment with vertical forces, we require that the one in the left goes down which it is, and the one on the right goes up, which it is actually. So we're correct. This disposition of forces will deliver exactly this moment if these forces have magnitude of 253.45 newtons each.